Chemical bonds are electrical attractions that hold atoms or ions together. Chemical bonds are the glue that connects compounds or elements. Elements are composed of atoms of the same element. For example, O2 consists of 2 oxygen atoms and 1 chemical bond. Compounds are composed of atoms of 2 or more different elements. There are many different bonds that are holding 3 different types of atoms together in this example. The first step of drawing Lewis structures is to identify the central atom. The central atom is usually the one with the lowest electronegativity. Write the symbol for the central atom and then arrange the symbols for the other atoms around it. So the example that we'll be using throughout the process is NF3. The central atom, the one with the lowest electronegativity, is nitrogen. So nitrogen will be in the middle. Around it, we will distribute the 3 fluorine atoms. Step 1 is finished. The second step is to add up the number of valence electrons available in each atom of each element. This number will represent the total number of electrons that you will draw in the diagram. If the structure is a polyatomic ion, you add 1 electron for each negative charge or subtract 1 electron for each positive charge. So for NF3, we're going to take a look at our periodic table of elements to determine the number of valence electrons. So for nitrogen, we can count 1, 2, 3, 4, 5. Nitrogen is found in the 5th column. This means there are 5 valence electrons. Fluorine is found in the 7th column. So there will be 7 valence electrons. In order to find the total number of valence electrons, you need to multiply the number of valence electrons by the number of atoms that are found in the compound. So NF3 only has 1 nitrogen atom, so we're going to multiply that by 1. But there are 3 fluorines found in NF3. So we're going to multiply the 7 by 3. Once we finish the multiplication and added them all up, our total is 26 valence electrons. So the third step is to place 1 pair of electrons between each adjacent pair of atoms. Every pair represents a bonding electron pair that forms a single covalent bond. The electrons that are remaining equal the total valence electrons minus the single bond electrons. So, going back to step 1, remember that our central atom is nitrogen, and it was surrounded by 3 fluorines. So we're going to place 1 pair of electrons between each adjacent pair of atoms. And we found in step 2 that we have 26 electrons to distribute. So let's place 1 pair in between nitrogen, each of the nitrogen fluorines, like this. So the electrons remaining equal the total valence electrons minus the single bond electrons. So we have 26 electrons to distribute. We've used up 6, so we are left with 20. Step 4 is to distribute the remaining lone pairs on the surrounding atoms. Okay, so now we've used up 24 of our 26 electrons, so we have 2 more electrons to distribute in the next step. 2 electrons left, so we can put them right here on top of our central atom, nitrogen. So we have a full octet on the central atom. If this was not the case, you would move the lone pairs from the surrounding atoms into a bonding position between those atoms and the central atom until all octets are complete. Check. If you're drawing a polyatomic ion, put square brackets around the entire structure and write the charge outside in brackets. Outside the brackets. So this is not a polyatomic ion, but if it was, you would just do square brackets like this, and you would write whatever charge, so 2 plus or whatever it is, outside just like that. But NF3 is not a polyatomic ion, so we're just going to leave it like this, and we are done. So now that we know how to draw a Lewis structure, we're going to talk about 3D structures. So what substances look like in real life in 3D space. There are factors that affect a molecule's 3D shape, and those include bond lengths and bond angles. 3D structure is very important, especially in determining how substances will behave and how substances will interact with other substances in real life. So, a substance may look to be linear when you're drawing it out in Lewis diagram form. However, when you draw it in VSEPR form, it may look something like this.
Nitrogen has the lowest electronegativity, so nitrogen was the central atom and chlorine will be distributed around it. Then we will use the periodic table of elements to add up the number of valence electrons. Nitrogen is in the 5th column, so it has 5 valence electrons. Chlorine is in the 7th column, so it has 7 valence electrons. There's 1 nitrogen atom, so we'll multiply 5 by 1, and there's 3 chlorine atoms, so we'll multiply 7 times 3. This adds up to a total of 26 valence electrons. To distribute these, first, 1 pair of electrons is placed between each adjacent pair of atoms. And then the remaining electrons are placed as lone pairs in the surrounding atoms. There are still 2 atoms left, so these will be placed in 1 pair around the central atom. Now all of our valence electrons have been used up, so we can check if the central atom has a full octet. There are 8 valence electrons around nitrogen, which means it's a full octet. So we can check the finished structures, and all of the atoms have 8 valence electrons, meaning they all have full, stable octets. So now that the Lewis structure is done, we can identify the number of bonding groups
There are 3 surrounding atoms. There's also 1 lone pair on the central atom. So now that we have the VSEPR notation, we can match that with the 3D sketch. AX3E is trigonal pyramidal. Our finished VSEPR diagram.